Yeah. Everyone hear me okay? Yeah? Okay, how many of you here are using agentic AI tools to build your software and tinkering around with it maybe? How many of your bosses know? Okay, yeah, so I'm here to talk about our experience of some concrete examples of actually modifying our software development lifecycle at Metropolis to really sort of transform things. So I know a thing or two about transformations, so I've been around a while. I might look young, but I've been around for a while. And the user side of AI tool, or AI, has really been like most transformative, even since the beginnings of the internet, which I was there for. And for the software development side, it's also reminiscent of the introduction of Linux and open source into our development lifecycle. Pretty soon, I think everyone here is going to be developing software in this way. So I've been, I went to a number of startups. I went to Google for 13 years, but now I'm back to my startup roots with Metropolis. So Metropolis, who's that? You have any idea of that? Well, someone knows. Yes, there's a bunch of them here. Just look for the shirts. So Metropolis actually started 7 years ago, before it was AI. They wanted to build checkout free experiences using computer vision. So they looked at a number of different areas. Of course, you could think of many of them, but, well, what about parking? So we started with parking, the most analog system you could ever think of. You have paper tickets, you've got cash. It's just a whole messy system, a messy real-world system that needed fixing. So imagine, what could you do? How could you make that good? Maybe just so you could just drive in and drive out and not have to worry about a thing. Well, this is what it looks like today. Actually, it's looked like this for a while, to be honest, but drive in, drive out, it feels like magic. You don't have your parking ruining your evening just by trying to find it. You have the ability to just not have to do anything. You just put your car in there. So anyway, so that magic started, and of course, a parking garage in this case, like every startup should, in Venice, California in 2018. But the big question is, once you perfect it, how do you scale it? Well, the best way is actually buying parking companies. So Metropolis bought Premier Parking, they bought SP Plus, and they are actually now the largest parking operator in the US. So you can see that they have 50 million members and they're growing 1 million per month. But of course, we wanted to scale out beyond that too, beyond just recognizing cars. Well, what about recognizing people? So Metropolis scaled out with an acquisition of a company called Usto. So we have a highly tuned recognition engine. We've got custom software, custom hardware, and which has led us to become more than just a parking company. It's a technology-led mobility company using AI, which is ML's vision has sort of progressed to. But of course, there's issues. How are we actually going to really scale out? And so we have some unique engineering challenges. So 7 years of deadline-driven development, a large monolith. How many of you here have monoliths in your code? A few, yeah. If you've been around long enough, they kind of come up just on their own. A lot of services. There's a lot of great stuff. It's a great cloud-based architecture, really good embedded software systems. We got a lot of Scala. I know Scala is popular here in New York. But the technical challenge, we had a lot of high-interest technical debt. So we thought to ourselves as engineering leadership, well, what are we going to do about that? Well, why don't we look at all the different things that we want to do? Maybe we could fix one or two of these. It's no, let's fix them all. So let's actually focus on the big picture of our software development lifecycle. So we went, like many of you, we were tinkering too. So back in January, we had AI assistant in our IDE. We had a bunch of other little things. We were experimenting with some open source tools like Aider. But what really changed it was the company got behind us. They said, here's the AI policy. You can use these tools. Go out and do it. So all of a sudden, we're able to fully take advantage of a lot of the things we had in our accounts already. So that whether it's an AI agent at Atlassian like Rovo, Gemini, just using Copilot as much as we want. And we had a Copilot pilot. So of course, everything has to rhyme. But in any case, we moved beyond that. So do everyone know what happened in May 2025? Is agentic computing really arrived full bore? It's hard to believe that it's only been since May, right? It's crazy. So Claude Code, Copilot came out with their agentic tools, and all of a sudden, we looked at this and said, this can really change things for us. So we went ahead and designed a trial of bringing 2 teams on with an AI native viewpoint. So we decided, like I said, look at the whole picture. Look at the whole system, and then we went ahead and just did it. So it's like basically you had to do your job, but you had to start with AI first. So here's our approach. So we brought each team on with a series of boot camps. We call them hackathons. They're really boot camps. So we basically the idea is we very quickly adopt the tools, learn from it, and then also like just define like what it's going to take to sort of scale it out. So every boot camp hackathon got better and better and better, and all of a sudden we realized that we were actually performing the functions of context engineering, which I'm going to talk about in a second. But the other aspect that we really wanted to also cover is like how do we go from an idea from the product side to the engineering side to actually launching it. So we had some great success. So like this was an idea for finding parking, and we just cranked it out in a week. It was done. So front end, back end, the whole 9 yards. So we saw, in addition to those simple things like that, we saw some 3 big patterns emerge. One is like the size of our tasks got smaller. So we call that t-shirt size shrinkage. So a large task becomes a medium task, medium becomes small. So, and that one it really just allows you to do so much more and also just take on things that you would never have even decided to try. The second thing was capability expansion. A back-end engineer can do front-end work. You can do lots more with the people you have. And then finally, the last thing is optimized workflows. So once you start looking at where the delays are in your system and you sort of stitch things together, boom, 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 you're just able to move much more quickly. So, okay, so let's go look at the data a little bit here. So this is a graph of lines of code generated by our engineers. Is it good? Do people think it's good or bad? Good? Bad? A little bit of both, actually. So some of the challenges we've encountered. So like, obviously, you've heard the term AI slop. Some people call it work slop, but people sending PRs without like, even reading them themselves. So this becomes, a problem. So the emerging science and engineering practice called context engineering is now upon us. So this is, uses a number of different techniques to try and minimize problems like that. So if you want good results, you have to set the stage, you have to give just the right amount of information where good results happen. So we didn't have very clear coding standards, so we got weird code. We did not have guardrails, so we had like failing tests. So, and we didn't have our systems connected, so the systems didn't know how to optimize things. So we did all this stuff. We did isolation, where we made separate agents. We have our own specific environment too. So we're a Scala shop, so we have a Scala agent. We had database migration, so we made a database migration agent, et cetera, et cetera, et cetera. So the other big thing that we did is also try and close the feedback loop. So whenever we finished with something, we'd say, how can we do this better? And you can use the tools to examine the tools because you have the whole context window available to you. So you can say, if you could do it again, what would have helped you? And also fix our environment to actually make it better. And then finally, we sort of started stitching things together. So like, we were able to go from a PRD to a set of Figma wireframes to a set of React components all in one go. So just boom, boom, boom. So this is connecting all these pieces together with a shared memory model is what has really allowed us to really perform well. So what's next? Well, first off, we have our AI developer program. So all engineers at Metropolis are now going to become AI engineers. So this is important to just put that out there. Just even for hiring purposes, you have to say, what do you think about AI? Do you like it or not? And also just for getting people into the right sort of same level of skill. We're building context engineering community practice, so that means that we're dispersing this knowledge throughout the company so people can develop their own agents, they can manage token size, et cetera. And they're also doing a more sort of process-oriented, tool lifecycle management. So we have tools now. Are they paying off? Maybe. Are they too expensive? Who knows? What about new stuff? You know, we got to keep track of that too. And of course, my favorite activity is the live coding. So there's nothing better than actually doing a live coding session to get people to understand the power of these tools. So it's just like, you know, getting past the, you know, the fifth level of asteroids or whatever. So you could actually, by watching someone else do it. So we do that every week, and other people are doing it too. So the takeaway, is that transformation, it can be successful. You don't have to tinker around. You can actually, you know, go full on with it and actually get real results. So the gains are possible. But the thing is, you have to like rethink, not tinker. So you have to force people out of their comfort zone. You have to say, you know, you can't like keep doing things the way you used to do them. You know, so you're going to be using these tools. So like, let's figure it out. Let's get past the impediments. Let's capitalize on the features, and let's, you know, move to execution. And then finally, I would say that context engineering is essential. It's going to be a core capacity for every engineering organization from now on. We have to be the orchestrators of the systems we generate, and we need to make a fertile environment in which software grows. So thank you.
How's everyone doing today? It's okay, I don't really care. I'm just stalling while I pull out my timer. Cool, okay, let's get into it. Hi, my name is Zack. I'm a software engineer at Hex, working on our AI agent, which we recently launched. I wanted to kind of walk through what the process was like today, going from an internal demo all the way up until pushing this thing out into the big wide world in production. So, cool. What is Hex real quick? It says it right there. Hex is a connected platform for using AI to work with data. If you're familiar with us, you're probably most familiar with our notebook tool, which I like to describe to people as like a Jupyter notebook on steroids. It lets you interop between Python and SQL cells. It's got like multiplayer functionality, a bunch of really cool stuff. And we recently just added an AI agent on top of that, which you can kind of get like a visualization of that over in the bottom right, I hope. Oh. Looks a little weird, but I swear it looks better in the product. Cool, yeah, that went really well. Hopefully this slide conveys that to you. Here's some quotes from companies you've probably heard of. We've got like tens of thousands of daily messages being sent, hundreds of thousands of messages sent so far, thousands of daily active users. Here's a definitely real chart that I pulled from some internal metrics, definitely not made by ChatGPT, that shows how well it's going for us right now. So yeah, it definitely didn't start off that way. It was a very long and arduous journey. We had AI features for a very long time, pretty much since the conception of Hex, but we hadn't invested in an AI agent until Sonnet 3.7 came out, right when agents started to get really good, and we decided to take another crack at it. I got a directive from our CTO that was basically like, hey, why don't you spend a week trying to build an agent into the notebook and just kind of see how it goes. And so that's exactly what I did. And I read a bunch of blog posts. I saw the Claude Code decompositions that used to float around there, all kinds of stuff, and pretty much wound up building something that looked like this. I would expect a lot of people in this room are probably pretty familiar with this diagram. I think this is typically what you see when you think of what is an AI agent. It's an LLM being called in a loop that's allowed to call tools, right? And this actually worked very well for V1. So well, in fact, that the C-suite got wind of it and decided, hey, let's go ahead and shove a bunch more resources over here and put this thing into production. And so I, in my naivete, assumed that what we would push into production would look pretty similar to this because it worked so well. And yeah, boy was I wrong, because this is what we ended up actually launching in production. And there's a lot more boxes up here, so it's obviously more complicated. Yeah, this is kind of the process that we went through. I want to kind of talk through today how we ended up from this going to this and try to justify to you why we have all these extra boxes up here. Cool, yeah, because it could happen to you. It's probably already happened to quite a few people in this room. You might wake up one day, get a directive from your CTO that it's time to build an AI agent, and like me, you might have no idea what to expect. So I kind of want to put you in the mindset of someone adding an AI agent into their product and just kind of walk you through what that process is like and what the hurdles we ran into. So the very first big hurdle that you run into, and the very first big hurdle that we ran into, was getting it to work. You can put it on some demo data, it works really well, it does all the little toy examples, and then you go and put it on real production data, and you find out pretty quickly that there's a level of resiliency that needs to be built into this agent kind of from day one. Anthropic goes down, and then the next day Anthropic goes down, and then it keeps going down every day for a whole week, and you realize that this is probably not going to fly in production. And especially once you start to add more tools, the model hallucinates tool names all the time, arguments as well into the various tools. Like an anecdote we had is that we have like a location parameter on most of our tools that allows the agent to decide where in the notebook it wants to insert a cell. It's just the UUID of the cell it wants to insert the new cell behind. And even though we have the prompt very explicitly that says, just leave this as null if you want the cell to be inserted at the front of the notebook, at the top of the notebook, it will still insert things like front or top or like root anytime it wants to put the cell at the top of the notebook. And so building that layer of resiliency into our agent was literally the first thing that we did just so that we could get it to even give the user back an answer. And once we did that, a new problem emerges, which is that it's not doing what you want it to. It's getting all the way through and giving a bad answer, or it's not giving the best answer possible. And so this is when you invest in things like observability, internal tools to understand and observe like what the agent's actually doing. A really big investment area for us here was how to evaluate. We'd had evals before for the previous AI features we'd done, but we never tried to eval an agent before. And if you've ever tried to do that, it's a whole can of worms. The strategy that we ended up going with was called LLM judge. It's basically this idea where you take an LLM, a different LLM, and use it to judge the responses of your agent. So you can have it do things like, how is this response? Is the code that it's writing effective? Is it calling too many tools, et cetera, et cetera? Cool, and so great, you've got an agent that runs all the way through to the end. You can see that it's not doing what you want. It's time to get it to do what you want it to do. And this is where we really started to invest in context management and really came to fully understand what context engineering actually is and what that takes. This is like a really deep topic, so I won't go like so deep into it, but one of the very first things that we did is just stuff like conversation compression, because the very first like big issue we ran into was just getting the context to fit inside of the context window, which might sound surprising, especially if you've only like built toy agents, but in production, there's lots of like huge data sets. People will talk to the agent for like hours and hours in the same thread. And so, conversation compression is an easy solution here. Just send it off to a different LLM, say, hey, can you give me a summary of this? And then use that summary as the new starting context in the next LLM call. I actually think most of the really interesting stuff, in my opinion, that's happening in kind of like context management has to do with how you trim the tools. Claude just released a beta feature that does this for you, but we've had to invent a lot of this ourselves. Ephemeral tool responses, dynamic tool trimming, virtual tool file systems, all kind of cool stuff. Cool. Whew. Awesome. So you're riding the wave. Everything's all good. Your agent freaking rocks. Everyone loves it internally. It's growing up in usage, and then you're feeling really good. One day you wake up and there's a DM from a security engineer on your team, and he sent you a Zoom link. You hop in that Zoom link. He pulls up a Notion doc, and that Notion doc has a link to like 6 research papers, like 20 articles, all about how AI agents are incredibly insecure and how easy they are to hijack and whatnot. And he's got like a very thorough, well thought through bunch of examples of how he's broken the agent already. And you kind of sit back and think, well, yeah, we haven't really thought that hard about that. And so this is another like big area of investment that we had to give into, which is how to actually secure the agent. There's a lot that we did here and continue to invest in. I think one of the things that was really interesting for us that might be unique is we ended up kind of like retooling our authorization system to work for our agent. So the reason that we did that is because when we started, we just allowed the agent to have the same permissions as the user that invoked it, which sounds good on paper, but if you sit and think about it, is actually a horrible idea. And one really like succinct example of why that's a bad idea is the agent on very, very rare occasions would edit like a cell that exists in a notebook that the user has access to, but was not actually working in at the current moment. So they would invoke the agent in that notebook, and even though the agent had access to all of the same notebooks that the user had access to, it really should only be editing that single notebook that the user is looking at one time. And so we had to retool our authorization system to work for the agent. Cool, and now you sleep a lot better at night. And it's time to actually, start to think about how you would scale this. You're a good engineer, so you sit down and you figure out what all the numbers are around, the scale. And 2 things really stick out to you. All those like bulk queue timeouts that you were ignoring would actually be a massive headache in production. And also, like AI agents are incredibly expensive. I don't know if you've ever seen like the margins for Cursor or anything like that, but they're very thin for a reason. And so 2 big areas of investment you need to invest in before you actually go and put this thing in front of a bunch of users is to figure out a more resilient system. Temporal didn't pay me to put them on the slides, but we really like them. This is a workflow orchestration tool that we switched to very recently, and they've actually spent a lot of time investing in how to make agent workflows very durable. So I would highly recommend checking them out and tell them I sent you and see if they'll pay me at all through that. And then prompt caching as well for keeping your costs down is another thing that was like really easy to just no-brainer turn on, but there's a lot more in there too. Cool, and now you can pop the champagne, celebrate, your agent's blowing up, you're feeling good, time for retro, let's see what you learned. And if you were like us, you might have learned 3 kind of core things from this. The first one was to keep the agent simple. If you're familiar with how to build agents, you probably noticed that I didn't say anything about parallel tool calling, sub-agents, any of the more sophisticated things. And that's because we actually built parallel tool calling almost right away and ripped it out really quickly because we realized that just getting the core agent basics right was so much more fundamentally important than adding all these extraneous extra features. And we're only now starting to add in parallel tool calling, sub-agents, stuff like that. And this goes hand in hand with the second point, which is, I think, be skeptical of a lot of existing best practices. And I apologize if anyone here has written like best practices blog posts or anything like that I may have read. But I would say that there's very few companies out there that have like agents running at scale, even fewer of them that write about those experiences. And so I think a lot of the online literature in this very nascent space is just from like hobby projects and things of that nature. And so, don't lose the engineering fundamentals through all the like hype and all the like things like that. Just go back to your core principles and think like, what is the thing that is actually right for my agent? What's actually driving engagement from the user? What's actually like, improving the evals? And then another like thing that we always fell back on, if we like really didn't know how to build something or what the right thing to do was always just to treat the agent as a powerful but very novice user who is obviously acting autonomously. And so I think when you're thinking about how to engineer something, think of it as just like another client, but it's a novice and powerful user, and that usually helps decide how you're going to build something. Whew. Okay, that was a quick one.
Problems with agents that OpenRouter solves. So Anthropic goes down every other day, as he said. And you can fall back to Vertex and Bedrock, and that's part of the thing that OpenRouter solves for everyone. We build an aggregator that allows you to use any model in any provider seamlessly with one integration. So you just need one API key for all models and all providers in the ecosystem. So OpenRouter is a very easy to use drop-in replacement for OpenAI, where you just take an OpenRouter key, use the OpenAI SDK, and you get to use any model you want. So you can use OpenRouter for Anthropic models, for Gemini, for open source and closed source. So we help with getting you the best prices, best uptime, and access to all the models on the platform. So would definitely urge you guys to go to OpenRouter.ai. We also publish a lot of open source rankings and metrics. And that's what I'm going to be using to talk to you guys about. So we've heard how people are using agents and agentic AI in their company, how people are building products with agentic AI. OpenRouter works with hundreds and thousands of AI startups and over 1 million developers who are building on top of AI. So we process a lot of tokens. We do about 5 trillion tokens every week right now. And it allows us to see a really cool bird's eye view perspective on the market. So here are a few learnings from everything that we've learned so far. The future is multi-model. For almost all companies that we see that graduate to having models in production, as Zack was just mentioning, you end up having not just the main model that you're going to, but also a fallback model. And then for each use case that you have, so you have an agent, you have an LLM as a judge, you have fallbacks, you have summarizers, categorizers. Each one you end up having to make a different trade-off between cost, quality, and availability. So you end up in a world with a lot of different models. Second, we were also talking about profit margins, and we are seeing inference become the dominating operating expense for knowledge companies. Payroll and servers have been the main cost for all startups for the last 30, 40 years, and we're really seeing that switch. A lot of AI native startups that we talk to, 80 to 90% of their total spend per month is now on AI models. Optimizing and orchestrating inference is going to be a really large horizontal market. What that means is there's a lot of different entry points and use cases that still need to be solved to really have AI in production. And I think Zack did a really good job of showing how many different steps there are to really building successful agents. And we really need both vertical integrations into ecosystems and horizontal platform layer solutions. So going back to the first point, the future is multimodal. To really underscore this, I wanted to tell you that we're mostly focused on Anthropic and OpenAI, but there are more than 3 large language models which are frontier quality that are dropping every single week. This chart shows the number of available endpoints. Endpoints are a combination of provider and model on OpenRouter. And in November, or like we ended the year in December with just under 400 endpoints. And about 2/3 of the, or 3/4 of the way through 2025, we're at 1,500 endpoints, and we expect to be at 2,000 by the end of the year. It's both an explosion of the number of models and the number of people providing them. So those are the big kind of mottos, but there's 3 trends that I wanted to highlight today that we think are really interesting and exciting and have shaped how inference is being used in the market. So the first, probably the most obvious one, is the rise of agentic inference. And obviously agent as a word is quite overused, and at this point I don't even know what it means, but for us it means tools that can reason and operate agentically. No, but so the first big change, and it really was a seismic shift that we saw at the start of this year, was the beginning of, or well, at the end of last year, was the beginning of reasoning models. So if you guys notice, right around October is this where this orange line starts showing up, and this is when OpenAI launched O3, the first reasoning model, and we're just seeing the very beginning of that. And then around the end of January is when we saw DeepSeek burst into the space. And that's really where you see this insane explosion in the amount of reasoning models on the platform. And now, in October 2025, around 60% of all models that are being used are reasoning models. And that really shows you how important it is to be able to see the reasoning trace and see how the model is thinking, not just to be able to complete the task better, but also to be able to debug it. It also allows the models to just perform better by adding more compute during inference. The second, tool calling is obviously growing. So this is how agents are orchestrated. You give them access to tools that are outside of LLMs. We see now like a steady state of around 20% of all requests are tool call requests. So these are not saying that requests that have a tool exposed to them. These are saying out of 100 requests made on OpenRouter every day, 20 of them, the model responds asking to use a tool. So 1/5 of all requests are actually asking for more context outside of the model. That's a very big trend that we're seeing. And then also average context lengths are improving. And that's partly because models are getting way bigger. We saw the first 1 million context length and 10 million context length model this year. Finally, the thing that, again, is probably like not that surprising is programming use cases tend to use way more tokens, and so you need to be way more careful with context management. So you can see, on average, overall token lengths are around 5,500 to 5,700, but programming prompts are used for programming, the average context length is around 20,000, more than 4 times higher. So the cost of those requests is also 4 times higher. The second big trend that we see in the market is that closed source is capturing the high dollar, high agency tasks that you need to, like you need more guarantee that they're correct. And open source is capturing low dollar tasks, tasks where it's okay to make mistakes. Again, these trends are shifting all the time. But so this chart shows the percentage of tokens for open versus proprietary models. The blue on the top is open source models. Yellow is proprietary. What we mean by closed source and open source is if the weights are available on Hugging Face. If anyone can take that model and put it in their own deployment, all of this data comes from within OpenRouter, but we can see that closed source models, so OpenAI, Anthropic, Gemini, primarily, continue to be a large percentage of all tokens that are consumed in the market, though we do see open source make big spikes. So the big spike that you see right here in August, which is really interesting. Anyone want to take a guess what this model was?
Is it 4.5? No, it's August.
No, this is the open source models.
Open source.
Open source model that, yeah.
OSS120B?
No. It was also a good model, yeah. Yeah, it was Kirby K2. So it's a model that not everyone has heard of, but if you, on our internal benchmarks and anecdotal evidence that we've heard from people, it continues to be a really good model for much cheaper cost to quality ratios than the closed source models. Another trend, obviously, is that coding continues to be one of the driving forces for inference. So it's a bit hard to read up here, but the categories are blue programming, orange is role play, red is technology. So those are the top 3 categories that you see here. And in October, coding constitutes about 50% of all prompts. The next is role play, so people that are just like chatting, storytelling, game playing. And that is around 20% of all prompts. Anthropic usage, so this is us breaking down what people are using Anthropic models for. Again, not surprising, 60% of all use is for programming, 20% is technology. So when you're not asking a coding question, but you're asking a technology-related question, so what are agents, what are LLMs? So those tend to be technology questions and not programming. And that constitutes about 80% of overall use for Anthropic models today. Anthropic versus DeepSeek, so this is really where it gets interesting because you can start to see how models really show the difference of how they're being used. Anthropic, totally dominated by coding. DeepSeek, totally dominated by roleplay. So for DeepSeek, it's almost 75% of all prompts are for people that are using it for roleplay. The third trend that we see across the market is that LLMs need to be globally useful. What does globally mean? 2 things. Globally for all use cases, and 2, truly globally across all countries. So new models can come out of anywhere and nowhere. Anywhere means all countries in the world are now working on AI models. China is leading very strongly. The huge blue, like this chart is just Qwen models. Qwen, until around July, was very, very small, doing like 50 billion tokens a week. And with one good release, with one Qwen 3, where we saw a bunch of different model sizes, they were able to 10x the amount of tokens that are being used on the platform. So you don't have to be a frontier lab to create good quality models. Anyone can do it. This is the demand that we see for OpenRouter. So 50% of our demand comes from the US. Europe continues to grow, so 20 to 30% of our demand comes from Europe, China, and then other countries. Chinese open source models are really, really good. Now they dominate the open source leaderboards. I think the top 6 open source models are from Chinese labs. The Qwen family is also the most fine-tuned family on Hugging Face. I believe it has the most number of unique fine-tunes, even more than Llama. And this is also usage of tokens across continents. We see obviously that in Asia, Qwen has a, actually I don't remember exactly what this chart is saying. But the mantra, sorry. What do we take away from all of the trends that we saw in the ecosystem? And I think Zack and all of the speakers today, they've really made the point, and we see it time and again with all of the companies that we work with. Start simple, eval early, and iterate fast. This is the mantra that we think makes AI agents successful, and we see companies that we work with adopt, and really it works very well for them. What does this mean though? So the first one is, how do you select a model? You don't want to start and test out every single model on the ecosystem because there's too many. So start simple, take any model that you like, take any frontier model, Claude if you're working with that, OpenAI, Gemini, whatever models that you use. Build the simplest agent that you can. Start collecting real world use case examples. Use LLM as a judge to eval those examples, and then iterate fast. So once you have a simple agent and once you have an eval set, then it becomes exponentially fast for you to be able to iterate over that agent and actually make sure that you can get useful work out of that agent. And So since agentic is the future, the second part of building agents is again the same thing, tools. And you want to do the same thing. Start simple, just with a prompt, no tools, build your eval set, and then start adding tools slowly, and you will see much better results than trying to add too many tools or too much of the context. So the main thing to take away for how to build agents from our experience is start simple, one prompt, one model, eval early, start getting examples of what you want that agent to accomplish, and then start evaluating that agent. Once you have those three things in, it's very easy and very quick. You can even make self-healing agents where you keep feeding in the output of your evals into an agent and asking it how would it improve the agent that you have. But you need the eval to be able to do that. And just to close off as well, that's like true for any experience that I have building agents, using coding agents, coding tools. The more guardrails, evals, metrics that we can supply to the LLM, the better it is at self-correcting and self-healing. And that's a really powerful tool that LLMs have that no other software tool that we have had in the past has. So we really should be using it to the most. Thank you.